All right, this is our practice test for Chapter 5, Functions Trig. Let's look at problem number 1 here on the practice test and ask, what quadrant is the angle 239 in? Well, I know that first quadrant goes from 0 to 90, second quadrant goes from 90 to 180, third quadrant goes from 180 to 270, fourth quadrant 270 to back to 0 or to 360. Now, how do I know that? It's because I've memorized it, and so do you. You need to memorize this setup right here for our angles. And we can see that 239 is greater than 180, less than 270. That means it's going to fit somewhere here in third quadrant. Okay, let's look at problem number 2. Okay, so it's asking here, is 48 degrees is supplement? All right, well, we have to know, sometimes this problem asks complement, sometimes it asks supplement. We need to remember that the complement is 2 angles added to 90. Supplement is 2 angles added to 180. Sometimes these two are confused. So if I'm given 48, what angle added to 48 is going to give me 180? Answer is 132, number B. Okay, on this problem, we need to have this formula memorized. We call this the arc length formula. That's the arc length. That's the length of this curved part. R is the radius that scribes out this circle. So this line and this line are both equal to the radius, because I just take this and I just swing it up this way. All right, theta is what we call this the central angle, and that's the angle between these two lines here that form this pizza slice. Okay, so this guy here has to be in radians, otherwise this formula will not work. Now, another thing that we have to watch out for is this guy and this guy has to be in the same units. For instance, if this thing is in feet and this thing is in inches, it won't work. I need to do a conversion to make sure I'm unit compatible. In this particular problem, I am unit compatible. I just substitute, do a division to complete my algebra, and we know that if I use this formula, my answer will be in radians. So that is in part D. Okay, let's continue on. Number 4. This is our go-to formula for converting degrees to radians. You have to know this formula. You have to have it memorized. More importantly, you have to know how to use it. Okay? So, degrees over 180, radians over pi. Plug in what you know. In this case, they're giving us negative 316. All right, so I'm going to solve this for radians, and I can do that with a cross multiplication. That works. Or I can multiply both sides by pi. These guys will cancel. That's how I ended up with this expression. All right, since this is the calculator portion of the exam, I whip out my handy-dandy calculator. Be very careful of order operations in your calculator. If you plug it in your calculator exactly like this, it's going to give you the wrong answer. You need to go negative 316 times pi, and one of two things. Either press enter or put this expression in parentheses, then divide by 180. Okay, the other one is I'm using this go-to formula again, but in this case, I'm given radians, and I need to convert to degrees. All right, so this is the setup. This is my substitution into this formula. How do I solve? Cross multiplication, or what I did is I took this side, multiplied it by 180. I took this side, multiplied it by 180. The 180 cancels out. So what do I have on this side? I have 12 pi over 9 divided by pi times 180. That's what this means. This means the exact same thing as this. All right, so I'm doing fraction math, so I made my pi over 1, so they both look like fractions. Dividing is the same thing as multiplying the reciprocal. These pi's will cancel out. So in the top I have 12 times 180. That quantity, or that product, divided by 9 gives me my 240. Okay, and let's finish up the last problem here on page 1 of our practice. Number 6 is going to be a bonus. And I've forgotten what page that is in your book. Oh, well, we're not going to worry about it. I'll try to give you all that later in class. Okay, so this is asking, I want the secant of this angle is what they're asking for. Well, I know the secant is the upside down of the cosine, so that would be the hypotenuse over adjacent. Okay, from the perspective of this angle, this is the adjacent, this is the opposite, this is the hypotenuse. I don't have a hypotenuse, but I can figure it out using Pythagorean's theorem. This cannot be reduced, so I just leave it as it is. And so then the secant of my angle theta is then my hypotenuse divided by my side adjacent. So that is answer A. Okay, we're going to cover page 2 in the next video.